Hi, this is Mitt with Gemba Automation. With the rise of digital manufacturing, many aspects of traditional manufacturing are being readdressed. Traditionally, the role of a CNC machinist had two components. The first one was a white-collar component. This meant that they were responsible for creating the program for the machine and for the part. The second is a blue-collar component, and that consists of running the equipment, so putting the raw material in and cutting the actual part. Now, with digital manufacturing, what's happened is those two roles have separated. We have one side, which is the white-collar component. The white-collar component being the CNC programming. Now, with digital manufacturing technology, anyone from around the world can do the program for this machine that I'm standing next to right now. Now, let's take a look at how this separation happens in the traditional taxi and Uber comparison too. So, in the ride-sharing world, the blue-collar employee has to do the driving, they have to get the gas, and do the maintenance. The white-collar components of the job are they have to locate customers and collect payments and do the billing. Now, the traditional taxi, they have to do the driving, they get the gas, and do the maintenance. However, they are also responsible for locating customers and collecting payment. Now let's take a look at how this has changed with Uber. In Uber, the driver still does the driving, they get the gas, and they do the maintenance. However, the white-collar components have been separated from the driver and are managed from the cloud. Therefore, in ride-sharing, this separation has taken place. Now here is an example of the great consolidation. So let's say we have 3 machine shops. Each of the machine shops has a mill and a lathe. At each of the machine shops we have a team member that's responsible for creating the G code for the mill and the lathe in addition to doing the machining. What digital manufacturing has enabled us to do is it's consolidated all the knowledge centers, so a team member that is extremely effective at creating code for milling machines can create that code off-site, and the same for lathe machining. Therefore, best practices for how to mill a part correctly can be spread from one central area to all of the shops that require that best practice use. So this is an example of how all of the work centers can be consolidated into one team member that is extremely experienced with milling machines and one team member that is extremely experienced with lathe machines. And now we have to ask ourselves, how do you validate G-code off of the production site? So, there are many softwares that allow you to do this. Here is an example of a Swiss part that needs machining. This is the part, and the software allows you to go from line 1 of the code all the way down, ensuring that the part is machined to print. Now here are the steps to validating G-code that was created off-site on the unit itself. The first step is the verification. What you do is take this code and put it in this controller. After you put it in this controller, you have to run it from line 1 to however many lines it is, just to make sure that there's no errors. Most controllers nowadays will tell you that there's an error before you even have to run any parts. After that is complete, what we can do now is do a dry run. So you do a dry run of the unit, and just to make sure that the part can be machined. You want to make sure that none of the tools crash into each other. You want to verify the speeds with your eyes. And then after that, we have step 2. Step 2 is cutting scrap parts. So we take a scrap piece of material, put it on the equipment, and then you cut it. just to make sure that the geometries are correct, just to make sure that everything is working the way that we need to machine this part according to the drawing. After that, there's step 3. Step 3 is loading production parts in here just to make sure that they're outputting the correct part. Now, within steps 1 through 3, what digital manufacturing has enabled us to do is capture many things on video and be as close to the unit without being here physically due to significant amount of video conferencing tools and communication tools and chat channels. So what we've shown you is how to validate the code off-site using a simulation and on-site using the unit itself. Now, as I've shown you, the world of CNC machining will look drastically different in the future than it did traditionally. This is due to the rise of digital manufacturing tools. Now, this can be a very good thing. This means that a problem that was solved in one facility can spread through the world and be solved in every other facility. So right now, it's more important to share best practices just to make sure that we're eliminating waste the way we need to and pushing our companies to success. Thank you very much. Subscribe to our YouTube channel and check us out at GembaAutomation.com. Thanks, guys.